Hi guys, BuildZoid here, and today we're going to be taking a look at the PCB on the EVGA X299 Micro 2 motherboard, which we have right here. So it's an MATX X299 motherboard, and this is the second revision of EVGA's Micro ATX motherboard, and as far as I'm aware, the main difference with this one is this here heatsink, which looks like an actual heatsink instead of a fashion accessory that you get on 99% of other motherboards.
Before that, this video is brought to you by Dollar Shave Club's Daily Essentials Starter Set. This full grooming kit ships at $5 and includes trial-sized versions of the company's popular shave butter, body wash, and wipes, and also includes a solid, high-quality razor and a full set of cartridges. Go to dollarshaveclub.com/gamersnexus to get the Daily Essentials Starter Kit for just $5 and with free shipping, or click the link below.
So this right here, this is very nice to see. It even comes with a little fan that is actually hooked up over a standard 3-pin connector. That fan is normally plugged into this fan header right here. So if you actually wanted to like replace the fan or get rid of it completely and then use like a larger fan to blow air over that heatsink, you can, and you can still have it hooked up to the same fan header with the same controls as the original fan had. So that's kind of neat. Also, this heatsink is very, very high surface area. So, I mean, yeah, this is what I'd like to see on a lot more motherboards. But, you know, it doesn't look very pretty, does it? But personally, I like the very sort of, this whole motherboard kind of has, in my opinion, a very business aesthetic. Like, there's not really any unnecessary fluff anywhere. Anyway, let's get into some of the overclocking features that it comes with. It's not that extensive, and then we'll get into the VRMs. So, right off the bat, you get a power button, you get a reset button, you get a post code. You also get a clear CMOS button. It's located on the rear I/O, and it's above, like, reasonably far away from all the USB ports. Somebody pointed out to me that they accidentally hit clear CMOS buttons on the rear I/O. Well, this one should be a tad harder to hit, because your USB ports are way below it. So, you know, that's that. And then you get a 6-pin power connector down here, which I think is completely unnecessary, because this is a micro ATX motherboard. And the reason why these 6-pin power connectors exist is basically to feed more power into your PCIe slots. The thing is, this connector right here, it has two 12-volt connections, so reasonably, like, you'll generally not want to push more than 240 watts through it. But on an MATX motherboard with only two, 16x slots, that's 120 watts per slot. Like, that's almost twice this normal specification. So this down here, this is unnecessary. On a motherboard that supports 3-way or 4-way, multi-GPU setups, I get it. I get why you'd want to have this. But on a motherboard that only goes to 2-way, I can't really think of a scenario where this will actually be useful. So, it's kind of pointless. I mean, it doesn't hurt anything that it's there, but it is kind of pointless because this is a micro ATX board. So that's that. And finally, you get also two 8-pin power connectors for your CPU, which makes sense because X299 pulls absolutely ridiculous amounts of power if you have one of the high core count CPUs and really, push the clocks on it. So yeah, that basically covers the sort of the more general stuff, and let's get into the VRMs. So the most important one and largest one is, of course, this one right above the CPU socket. This is the VCC in, and it is controlled by this chip right over here, which is a International Rectifier 35201, which technically now is Infineon, because Infineon recently bought International Rectifier. Now, that is a up to 8-phase voltage controller, but here it's running in 5-phase mode. Then there's 5 of these chips, which you can't see all of them, but that's fine. there's 5 chips down there, and those are IR3599s, and those are running in doubling mode. So you can probably guess what we have here in terms of phase count. This is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 phase. And the 3599 is not exactly the brightest doubler on Earth, mainly because it's based on, it's actually a quadrupler. So you could, if you wanted to, if EVGA felt like it and there was enough space on this board with this controller and this doubler, well, this chip right here, you could actually have a 20 phase. But here it's just configured for 2-phase configuration because as far as I'm aware, IR doesn't actually have another dedicated doubling chip. So they have this thing and that's it. Like, this is the only one you can get. If you want to double, you buy this. If you want to quad, you buy this. But the issue with this thing is it's not, like, it doesn't do any current balancing at all. Which means that you do get like a 10-phase interleaved output. It's just not very clever. So if one of the phases, for whatever reason, like on a load transition or something, ends up pushing way less current than the other phase on the same doubler, the voltage controller will not know about it and it'll ignore it, because the voltage controller, the 35201, still sees the entire VRM as groups of basically 2 phases. So you like groups like this, those can be current balanced. So if you had way too much current going through these two relative to everything else, then these two would get reduced duty cycles for a bit to bring all of the other phases up to equilibrium with, like, to equal current output. But if you have a current imbalance between this power stage and that power stage, you can't do that because the 35201 has no idea that these two are actually separate phases. As far as it's concerned, this is one phase, and the 3599 doesn't do anything either. That chip has 8 pins. PWM signal goes in, PWM signals come out. That's basically all that chip does. So it doesn't have any monitoring or logic in it, or like more advanced logic in it. So this is like it's a 10 phase. It counts as a 10 phase. It's just kind of dumb. So the actual power stages used here are IR3556s, which is not the most powerful power stage, and I can't write today. So 3556, that's a 50 amp power stage, and that means your theoretical maximum output for this entire VRM is 500 amps. This is actually above the maximum theoretical output of any Asus X299 motherboard, which is, in my opinion, extremely disappointing. Not for this board, but for the company. Like I'm disappointed with the Asus motherboards. Like this, you know, because the thing is, like, Asus has a Rampage 6 Apex, and that's still stuck on an 8 phase. And then there's this thing, which is just, this is an MATX motherboard. It's probably never gonna see liquid nitrogen, unless I decide to put it on liquid nitrogen, because EVGA did send me a review sample of this motherboard, which is why the picture quality is terrible. So that's, if you're wondering why what's up with that, it's because I took the picture. And since I can since I have the board in hand, I can read the chips myself. I don't need the photo for that anymore. So anyway, max output is theoretically 500 amps, though if you were actually running that, you know, if you had a Skylake X CPU and you had to push 500 amps, which on liquid nitrogen, you just about might hit that kind of current output. Kind of like, not really, but you can get pretty close to it. 500 amps, 2 volts, you would be looking at about 130 watts of heat output on this VRM. And at that point, this heatsink right here would not be adequate. But that's why EVGA makes the X299 Dark, because the X299 Dark has a 12 phase, a bigger heatsink, and at that kind of power output only produces about 96 watts of heat instead of 130. So that gives you some reference point for why, you know, we have even stronger VRMs on the extreme overclocking boards. But looking at more reasonable applications like, say, well, if you wanted to run an X299 chip on Air, you can. So if you were on Air, you'd be looking at around 200 to 300 watts of CPU power consumption, because much more than that, and your heatsink is not going to deal with it. That's just kind of a hard limit for air cooling, though. I don't know. Maybe if somebody, like, if there was like a heatsink with like an absolute ton of heat pipes, they might be able to exceed that. But all of the ones that like I've dealt with, you basically like you swap out the fans for something ridiculously loud, and you're still stuck at 300 watts for sort of maximum heat dissipation. But 200 to 300 watts for those kinds of power levels, the VRM would only be producing 14 to 20 watts of heat, which is slightly more than what the X299 Dark would do under the same under the same power output. But then again, the Dark has a much bigger VRM. This kind of heat output on the VRM should be no issue for this heatsink right here, especially because it has forced airflow through because of the fan. So that's great. And then for water cooling, you're going to be looking at 300 to say 500 watts. You can actually push 600 watts ish on water cooling if you have a seriously massive water cooling loop. But generally speaking, you're going to top out around 500. Going much above that is it's not really practical on water. Actually, it's just not really practical in any circumstances to go above 500 watts worth of CPU power consumption. So with 300 to 500 watts of power consumption, the motherboard would be producing 20 to 39 watts of heat on the VRM, which that should still be well within the capabilities of this heatsink, mostly because of the fan. If it didn't have the fan, then like I think anything exceeding much more than 25 watts would actually start being problematic, because this does have a pretty high fin density, and so like its passive cooling capabilities aren't going to be exactly incredible. But the way this is actually set up is that fan blows basically into like these there's basically channels set up for air to go through like those fins right here that I highlighted. And so the fan actually blows into those fins directly, and then you'd have hot air exhausting out the top and bottom of the heatsink. So it's a really good way to design it, because yeah, it massively improves the VRM cooling situation. And also EVGA has a very thin thermal pad on the bottom of that heatsink, which really, really surprised me, because a lot of motherboards, they'll go for like ridiculously thick pads, because the thicker your thermal pad, the worse your manufacturing tolerances can be. But EVGA is using what looks like a 0.5 millimeter pad, which is like the smallest normal thermal pad thickness that you would normally see. So yeah, that heatsink should have that heatsink basically makes this motherboard a lot better than a lot of the other X299 boards, because VRM wise, this is comparable to a lot of motherboards. It's better than some, it's worse than others, but there's not that many boards that come with this to cool the VRM, and this makes a huge difference. So I really, really like that right there. So that covers the VCC in. It might be viable for liquid nitrogen, but I already have the X299 Dark, so I don't see a good reason to abuse this little board. But if it turns out that the BIOS is actually capable, which it might be, because this board doesn't versus the Dark, the main loss on this motherboard is that the Dark has a whole bunch of LEDs scattered around it for easier troubleshooting, which is really handy when you're on liquid nitrogen and stuff stops working and you're going like, well, I don't know what isn't working, and the postcode isn't being helpful. Then those LEDs are really, really useful. But those are all missing here. But there's plenty of other boards that don't have them, and you can run those on LN2 fine. So if this, I don't know, it might be viable, but it will really depend on if the BIOS is up to scratch, because there are certain voltages that you need to have control over, and voltage ranges, which is, I think EVGA might not give you ridiculous voltage range on this board, just because it's meant for high power MATX gaming builds more so than, or like editing builds, or well, whatever you want to do with an MATX form factor motherboard with an X299 CPU, just not LN2, because they have another board for that, and that's the Dark. But this does still have the 2 memory slot, like 1 memory slot per channel situation from the Dark, so I'd hope that it's decent at memory overclocking as well. And at that point, you know, it's just like, well, does it have the voltage? Because the VRM would mostly be okay until you like hammered an 18 core or something. Like the 18 core gets ridiculous, but the other chips, it should be able to handle those. So that's the VCC in there, and then we move on to the minor rails, starting with VCCSA and VCCIO. And since I don't know which one is which, and my best guess is that this is VCCSA and this is VCCIO. Well, they're both controlled by this chip right here. So basically that'll be like that in terms of controls. And that chip is a IR35204, not a 01. This is basically, it's the same family of chip as the 35201. It's just a lower phase count, which makes it cheaper. Here it's running in a 1+1 configuration for the VCCIO and VCCSA. The power stages are again 3556s, which is ridiculous overkill for these rails because neither of these does very much, especially if you're on ambient cooling. VCCIO and VCCSA, my recommended range for both of these is like 1.1 volts VCCIO and 1.05 VCCSA. There's no reason to raise them higher than that. And in fact, even on liquid nitrogen, I end up running VCCSA around 1.05 and VCCIO at like 1.35. Because on LN2, it really helps with mesh overclocking. But on ambient cooling, I've not actually noticed any benefit from raising either of these. And I did all of my ambient benchmarking with the X299 Dark around 1.1 volts for both. So yeah, you know, neither of these needs to do a whole lot in terms of moving power. Both of them for 15 amps output at 1.2 volts, assuming you would set it to 1.2 volts, because the power efficiency gets a little bit better if you go for lower voltage. 15 amps, 1.2 volts, you'd be looking at about 1.3 watts of heat for each, which, you know, they don't have heat sinks, so it makes sense that EVGA opted for ridiculous overkill, though there are plenty of motherboards out there which for VCCIO and VCCSA go with much weaker single-phase VRM designs compared to this, because, again, like, these are not high-current rails. So, yeah. This is just overkill. This is nothing to complain about there. Moving on. We get the memory, and you can't see anything on that side because it's all blurred. Well, this side's not that much better, is it? But the memory situation is similar on both sides. So you have 2 phases. They're separate. They're not together. There's another IR35204 running, I assume, 1+1 again, because I've not actually managed to, well, I don't have a pinout for these chips, so I can't actually figure out what they're wired up to, because I can't check where their PWM signal lines go. But I'm assuming what's going on is, so this one's VDDR, just because that's where the VDDR rail normally sits, and then this one should be VPP. And both of these are controllable in software, I assume, so they're going to be hanging off of the 35204. So, yeah, and both of those, and actually for the actual power stages there, these are not the 3556s, I mean, they're a lot smaller. These are TDA 88240s from Infineon, which is basically the same as all the international rectifier stuff at this point, because IR is owned by Infineon. But the TDA 88240 is a 35 amp DR MOS part, and that's basically a type of power stage. And I think it's actually just a naming convention difference between Infineon and a lot of the other manufacturers, where a lot of the others will call their stuff power stages, which, as far as I'm aware, power stages are all technically direct MOS. anyway. So, yeah. So Infineon calls this a DR MOS, whereas like International Rectifier considers the 3556 a POW IR stage. Yeah, because, you know, spelling power with E is just too mainstream when you can spell it with I. But it makes sense. But so power IR stage. So you have the POW IR stage from International Rectifier, and then you have just DR MOS for Infineon. 35 amps output for memory power is ridiculous overkill. DDR4 really doesn't pull that much current. So yeah, I mean the X299 Dark was a similar situation where there was like a 60 amp power stage from Intersil on the memory, and that was just like more overkill. So yeah, this is slightly less overkill, but still very, very overkill. And the same applies to the VPP rail. Like, this barely pushes any, like, this pushes even less power than the VDDR. So this is basically like using the TDA 88240. I mean, the 88240 is mainly a cost-saving measure, because I know in EVGA uses this power stage, DR MOS, well, it's a type of power stage, so power stage on a whole bunch of other motherboards, like the Z3, like I think most of their Z370 lineup uses these, so for like VCore and everything basically. So since they have a bunch of them for those boards, I assume the logic was, well, we already have a ton of these, we can just smack them onto the MATX board where we don't need the current handling capabilities of the 3556s. So, and on the other side of the CPU socket, you get the exact same thing, 35204, VDDR, VPP. So it's actually basically mirrored right across the CPU socket. So yeah, that's pretty much it for the board. There's not really much else left. Well, actually nothing left at this point. So this, on like hardware wise, I have nothing to complain about. You get your 2 8-pins, you get a very powerful dumb 10-phase VCC and VRM, which will also run VCore if you use a Kaby Lake X, but Kaby Lake X is just this thing that shouldn't really exist. So, you know, you have your nice powerful VCC and VRM, VCCSA and VCCIO are both massive overkill because they need to actually cool themselves through just the surface area of the chip and the surrounding PCB. So, you know, massive overkill is the easiest way to achieve a scenario where they won't overheat. Memory power is massive overkill. You get some basic overclocking features. Like, you get basically the bare minimum to get around with. And you get this unnecessary 6-pin down here. So, yeah, not much to complain about, considering that this is, you know, not like a top of the line board. Very well balanced, I'd say. And I think, like, I still think this could be viable as like the cheaper alternative to the X299 Dark. So I may or may not, well, we'll see. Like, I still need to get around to testing the board, but hardware raw wise, I really like what I'm seeing so far. So that's it for the video. Thank you for watching. If you'd like to support Gamers Nexus, there's the Patreon, as well as store.gamersnexus.net. And if you'd like to see more overclocking related stuff, PCB breakdowns and such, I have a channel called Actually Hardcore Overclocking, where I do a bunch more of, you know, PCB breakdowns and other overclocking related content, as well as live streams and overclocking with liquid nitrogen guides, that kind of thing. So yeah, that's it for the video, and goodbye.